Hello class, welcome to exercise 5D, Factorising non-monic quadratic trinomials. In today's lesson, your examples and pre-learning will be example 10, Factorising non-monic quadratics. And your pre-learning for this example will be questions 1 and 2 in the new book and questions 3 in the old book. And then we'll do example 11, where we'll simplify algebraic fractions using quadratic expressions. And your pre-learning for this will be questions 7 in the new book and questions 8 in the old book. So this is the final of 3 lessons where we use the grouping method for factorising, quadratics and trinomials. Mastering the first 2 lessons is necessary to be successful today. So if you haven't mastered it, make sure you go back and do those last 2 lessons. Okay, I'll see you in the introduction. Okay, let's start this lesson by trying to use a grouping technique to factorise the quadratic 2x squared minus 3x plus 2. So first we need to find the factor pairs of 2, which are 2 and 1 and minus 2 and minus 1, that add up to minus 3. And minus 2 minus 1 is equal to minus 3. So we can rewrite that as 2x squared minus x minus 2x plus 2. Where we've replaced minus 3x with minus x and minus 2x. And now we can group those. And in the first group, the common factor is x, and the second group, the common factor is minus 2. However, this doesn't lead to common binomial factors. So we're going to need to tweak our technique to take into account non-monic trinomials. Non-monic trinomials are a times x squared plus bx plus c, where a is not equal to 1. So some examples of these would be 2x squared or 3x squared plus 4 or 5x squared minus 2x plus 3. So the point of this lesson is to learn how to factor non-monic trinomials. But let's start by investigating expansion. Let's look at the binomial product of dx plus e times px plus q, where d, e, p and q are just constants. So when we expand that, we get dp times x squared dqx plus ep times x plus eq, just by using FOIL. And this becomes dpx squared plus dq plus ep times x plus eq, just by collecting like terms. So for our non-monic trinomial, ax squared plus bx plus c, a is equal to dp, b is equal to dq plus ep, and c is equal to eq. So we can see that dp affects a and b, and eq affects b and c. So instead of just focusing on factor pairs of c, we need to focus on factor pairs of ac, i.e. a times c, that add up to b. And this is because ac equals dp times eq, because dp is a and eq is c. And by rearranging those factors, we could just make that dq times ep. And we know that dq plus ep is equal to b. Okay, so I know this might be meaningless algebra to some of you, but please come back and read this after you master your examples if you want to have complete understanding. Now, what does this look like with an example that has actual numbers, such as 4x squared minus 4x minus 15? So in this case, a is equal to 4, b is equal to minus 4, and c is equal to minus 15. Now, a times c is equal to 4 times minus 15, which is equal to minus 60. So therefore, we want factor pairs of minus 60 that sum to minus 4. In other words, factor pairs of AC that sum to b. So factor pairs of minus 60 are 1 and minus 60, which sums to minus 59, 2 and minus 30, which sums to minus 28, 3 and minus 20, which sums to minus 17, and 6 and minus 10, which sums to minus 4, which is exactly what we want. So in other words, 6 times minus 10 is equal to minus 60, and 6 plus minus 10 equals minus 4. So let's start again with that 4x squared minus 4x minus 15. Well, that becomes 4x squared plus 6x minus 10x minus 15, just by subbing in 6x minus 10x for minus 4x. And now we can group those, and taking out the common factor for each group, we're left with 2x times 2x plus 3 minus 5 times 2x plus 3. And we'll just highlight how the groups are still the same. Now you can see both groups have 2x plus 3 as a common factor, and therefore our final answer is 2x minus 5 times 2x plus 3. Just like we asked in the last lesson, does order matter? Well, no. We could have written the second line above as 4x squared minus 10x plus 6x minus 15 just by switching 6x and minus 10x. Then once again we can group these, and taking out the common factor in each group, we're still left with a common factor. The only difference is we've ended up with the other binomial factor as the common factor. And now we end up with 2x plus 3 times 2x minus 5, which is exactly the same as above, just our binomial factors switched around. And just as I said in the last lesson, if you're ever unsure, check. Now we've ended up with 2x minus 5 times 2x plus 3. And by FOIL, the first one is 2x times 2x, and the outside is 2x times 3, and inside is minus 5 times 2x, and last is minus 5 times 3, which is equal to 4x squared plus 6x minus 10x minus 15. And by collecting like terms, we get 4x squared minus 4x minus 15, which is exactly what we want. Alright, so this is the end of the introduction, but for this lesson I suggest you pause the video now and work on the building understanding questions in the new book, which translates to questions 1 and 2 in the old book. While we don't always do pre-learning for the introduction, I think that it's really important to practice finding factors of AC that add up to B for a trinomial described as ax squared plus bx plus c. If you're confident with grouping from our last lesson and this concept, then this lesson will be very easy for you. Alright, I'll see you in the next section. Let's summarise what we've covered in the introduction. To factor non-monic trinomials, such as ax squared plus bx plus c, first we find the factor pairs of a times c, then we choose the factor pair of ac that sums to b, then substitute these factors for b, and finally we factor with grouping. Okay, so let's just get straight into example 10, where we're going to factor the following. First up in part A, we have 6x squared plus 19x plus 10. So here A is equal to 6, B is equal to 19, and C is equal to 10. So we need to find factors of 6 times 10, or 60, that sum to 19. So factor pairs of 60 are 1 and 60, 2 and 30, 3 and 20, and 4 and 15. Now 4 plus 15 equals 19. And we can stop there because we've found a factor of 60 that sums to 19. So we can now write this trinomial as 6x squared plus 4x plus 15x plus 10. Because all we've done is take this 19x and rewrite it as 4x plus 15x. And now we can group this and see that the common factor in the first group is 2x and the common factor in the second group is 5. So we now get 2x times 3x plus 2 plus 5 times 3x plus 2. And we have a common factor of 3x plus 2. So we can now rewrite this totally factored as 2x plus 5 times 3x plus 2. And we're done. Alright, let's move on to part B, where we have 9x squared plus 6x minus 8. So obviously A is equal to 9, B is equal to 6, and C is minus 8. So AC is equal to 9 times minus 8, which is minus 72. And factor pairs of minus 72 are 2 and minus 36, 3 and minus 24, 6 and minus 12, 12 and minus 6. And we can stop there because 12 minus 6 is equal to 6, which is B. Let's rewrite this trinomial as 9x squared plus 12x minus 6x minus 8, simply by changing this 6x to 12x minus 6x. And if we group this, we can see that the group on the left has a common factor of 3x and the group on the right has a common factor of -2. And therefore we're left with 3x times 3x plus 4 and -2x times 3x plus 4. And clearly 3x plus 4 is a common factor. And we can finalize this factorization with 3x minus 2 times 3x plus 4. And the pro tip is, if you're unsure at this point, expand your answer to see if it gives you the question. In other words, does 3x minus 2 times 3x plus 4 expand to 9x squared plus 6x minus 8? And there's no reason to make a mistake on a test if you perform this check. Alright, at this point you should pause the video and work on questions 1 and 2 in the new book and questions 3 in the old book. And then come back and I'll see you in the next section. As you know from the last lesson, simplifying algebraic fractions when there's quadratics involved is not as challenging as it looks. All you have to do is first factor both numerators and denominators, and then simply cancel out the common factors. Alright, let's get straight into example 11, where we're going to simplify 4x squared minus 9 divided by 10x squared plus 13x minus 3 multiplied by 25x squared minus 10x plus 1 divided by 10x squared minus 17x plus 3. Whoops, I forgot the squared for 4x squared. Let's simplify each of these quadratics, starting with the 4x squared minus 9. Well, that's just equal to 2x squared minus 3 squared, which is equal to 2x plus 3 times 2x minus 3 by difference of perfect squares. And because minus 5 times minus 5 equals 25 and 5 minus 5 equals minus 10, therefore 25 squared minus 10x plus 1 is equal to 25x squared minus 5x plus 1. And taking out common factors, we end up with 5x times 5x minus 1 minus 1 times 5x minus 1, which equals 5x minus 1 times 5x minus 1, which equals 5x minus 1 squared. I should have noticed the perfect square there. But these are a little bit different than our monic perfect squares, because ax plus b all squared is equal to a squared times x squared plus 2abx plus b squared. Anyhow, let's move on to the next one. Minus 30 is equal to 15 times minus 2, and 15 minus 2 is equal to 13. So therefore 10x squared plus 13x minus 3 is equal to 10x squared plus 15x minus 2x minus 3, which is equal to 5x times 2x plus 3 minus 2x plus 3, which equals 5x minus 1 times 2x plus 3. And lastly, 30 is equal to minus 15 times minus 2, and minus 15 minus 2 is equal to minus 17. So 10x squared minus 17x plus 3 is equal to 10x squared minus 15x minus 2x plus 3, which is equal to 5x times 2x minus 3 minus 2x minus 3, which equals 5x minus 1 times 2x minus 3. So with all that in mind, let's write out the original algebraic fraction. And we can substitute in 2x plus 3 times 2x minus 3 for our 4x squared minus 9. And for the 10x squared plus 13x minus 3, we can substitute in 5x minus 1 times 2x plus 3. And for the 25x squared minus 10x plus 1, we can substitute in 5x minus 1 times 5x minus 1. And for the 10x squared minus 17x plus 3, we'll substitute in 5x minus 1 times 2x minus 3. So we've factored all those quadratics. So let's find the common factors. And don't forget we can cross cancel. So here we have 2x plus 3s, so let's cancel those out. And 2x minus 3s, and 5x minus 1s, and another pair of 5x minus 1s. So everything's cancelled out there. Of course, everything here is times 1, so we end up with 1 divided by 1, which is just equal to 1. Wow, that huge complicated thing is just 1. That's a bit weird. Well, they really wanted to ram home their point about factorising, didn't they? So I know I went through that really quickly. Hopefully you're able to at this stage as well. But if you need to double check, by all means go back and try your own factorising for each one of those quadratics. Alright, it's time for another pro tip, and that is, despite learning all these cool new techniques, you really do have to still keep your eyes open for difference of perfect squares and perfect squares. And right about now you should pause that video and work on question 7 in the new book and question 8 in the old book. And then come back and we'll summarise this lesson. Okay, this is the last of 3 lessons where we've learnt how to factor by grouping. If you still remain unclear, apart from asking me, you can work backwards to expanding binomial products and see how each lesson builds upon the previous one. While we're going to be learning other techniques, this is important for real-world applications and quadratics and graphing parabolas. Okay, so for this lesson, a successful student will understand the relationship between expansion and factorisation for binomial products, as well as know and be able to apply the process for factorising non-monic quadratic trinomials. Alright, that's it for the lesson. Work hard. We'll see you in class or the next video. Bye.